Good day to you, students. How are you and everybody at home? It is time for basic science. And the topic we want to discuss this hour is kinetic theory. Kinetic theory. Kinetic theory of matter. Kinetic theory of matter. Matter is defined as anything that has weight and occupies space. And Dalton, in his atomic theory, explained that matter is made up of tiny particles, which he called atoms. These tiny particles are always in constant motion. He said a lot about atoms. Apart from that, last time when we were discussing forms of energy, we mentioned mechanical energy, which can be divided into potential energy and kinetic energy. Potential energy is the energy that the body has by reason of its position. We also call it energy at rest. And kinetic energy is defined as energy that the body has by reason of its motion, which is energy that a body that is moving possesses. Energy possessed by a moving object or body. Putting these things together, we can see that kinetic theory of matter is a theory that deals with energy due to movement of particles. Energy due to movement of particles. What do we want to discuss mainly under this topic is that we want to talk about the basic assumption of kinetic theory of matter. These theorists postulated some assumption, and out of this assumption I want to give you three main points out of these assumptions postulated by the theorists. Number one, the man said that matter is made up of tiny, very minute particles, which can be called atoms, that are always in constant motion, and at the same time they possess kinetic energy. They move constantly, randomly, and they possess kinetic energy. Not only that, number two, the man said that when there is increase in temperature, that is on heating, there is increase. There is always increase in movement of this particle. There is always increase in motion of this particle, and this normally cause increase in average kinetic energy. When there is increase in temperature, this causes increase in motion and can result in increase in average kinetic energy. And number three, the man said as a result of increase in kinetic energy, there may be change in state of matter. There may be change in state of matter. Again, I want to say that matter, the man said, number one, that matter is made up of tiny particles which are always in constant motion and possess kinetic energy. Increase in temperature increases the motion or movement of this particle, which can cause increase in average kinetic energy. And number three is that when there is increase in average kinetic energy, there may be change in state of matter. Take for instance, ice block can be called solid. Ice block can be called solid. When there is increase in heat, it may change to water, which is liquid. And when you still continue to heat, it can change to vapor. It may change to vapor, water vapor, which is in gaseous state. What are we talking about is that when there is increase in temperature, there may be increase in the motion, movement of particle, which can result in the change of matter. Those are the three basic assumptions I want to give to you. Now, let's continue. I want to talk about states of matter. Matter exists in three states, namely solids, liquid, and gaseous states. We have solid, liquid, and gaseous states, which you people call gas. According to the theorists, according to kinetic theory of matter, we want to explain movement of particle in solid, liquid, and gas. Now take number one, solid. Solid. Particles in solids are closely packed, firmly held together by forces of cohesion. They are closely packed, firmly held together by forces of cohesion. Because they are closely packed and firmly held together, there is a kind of restriction. They are not so free, so they can only rotate about a fixed point and vibrate. Can only rotate about a fixed point and vibrate. And they are not free to translate. What do we mean by to translate? Is that they are not free to move about from one place to another. Because of this, there is less kinetic energy between the particles. The particles are not, the kinetic energy is so small. It's so small. The particle possesses less kinetic energy. And because of this, we can see that solids have definite shape, definite volume, and are so difficult to compress. Solid has definite shape, definite volume, so difficult to compress. Take for instance, this is a solid. This is a solid. It has definite shape, definite volume, and so difficult to compress. You cannot compress solid. Take for instance, we have examples of solids like chalk, stone, book, and many other ones. Now we are going to another state of matter called liquid. Liquid. The particles in liquid are further apart. They are not so much held together in a fixed position. They are free to move within a particular restricted space. They can vibrate, rotate, and translate, but within a particular restricted space. And because of this, particles in liquid possess greater kinetic energy than particles in solid. They possess more kinetic energy. And as a result of this, liquids have definite or fixed volume. No fixed, they have definite or fixed volume. They are not easily compressed. You cannot compress them easily. And they don't have definite shape. They only normally assume the shape of the container. The shape of the container. For example, water is a liquid, kerosene, petrol, and other. They are all liquids. You cannot compress liquid. We have what? They normally assume the shape of the container. Take the shape of the container, but with definite volume and cannot be compressed. That is that about the gas. the liquid. Then we are now going to gaseous state. Gaseous state. The gaseous state. Gases, particles in gases are further apart, so free to move. They move in all directions, randomly, constantly, only being restricted by the container. Being restricted only by the container. They are so free because they are further apart. The forces or the cohesive forces between the particles is negligible. The cohesive forces between the particles are negligible. What do we mean by negligible? Is that it's so small compared to what we have in solid and liquid. Particles in gases possesses very much more kinetic energy than what we have in solid and liquid because they are so free. Looking at this, they are so free and they normally move with great speed in all directions, colliding with the wall of the container, so free to move. And as a result of this, they can be compressed. Gases can be compressed. No definite shape, no definite volume, but the gases can be compressed. That is what we have under gaseous state. Today, I've been able to discuss with you kinetic theory of matter. Basic assumption of the kinetic theory of matter, and we have talked about states of matter, the solids, liquid, and gaseous states. I want to give you an assignment. The assignment is that you will state 5 factors affecting evaporation. 5 factors affecting evaporation. 5 factors affecting evaporation. Next time we meet, we'll discuss more about kinetic theory of matter. The assignment states 5 factors affecting evaporation. State 5 factors affecting evaporation. Till then, goodbye. God bless you.